Hello, I'm Nobby. Welcome to my workshop. We're continuing on with the build of the PM Research engine. In my last video, I showed machining the cylinder end caps, the size. So the final job on these is to drill the clearance holes for the little screws that will hold the cylinder caps to the cylinder. This is the furthest cap from the operating end of the cylinder. Then this one requires 4 holes drilled in it. So I've set this up in my rotary table. I've put my 3-jaw chuck on the top, and you see I've got a couple of parallels in here. So I press this down against the parallels to keep it nice and square, and I'm using the parallels to support this while I drill the holes. Before I mounted this in the chuck, I did use a scriber to mark positions all the way around. It's just a sort of, I feel like a sanity check, just to make sure everything was in line. But what I did was set this up, moving the X and Y movement of the table to line up a pointer here with the centre of the rotary table first, and then when I put this into position, I had already, when I was machining this, put a little centre mark in here so I could then double check that aligned as well. So it's now just a process of going around and drilling the holes. I've already drilled one just to make sure everything is working properly. So what I'm doing is put the spotting drill in, and then move the table round to the next position, which is at 90 degrees. So there we are at 90 degrees. And we lock the table. I think I just have to move this one around a bit so that I don't drill through the parallel as well. I'm going to take that out and put that under here, I think. It's just really to give just a little bit of extra support. So that will come down, so that will be then at a 90-degree angle to that one. These are basically clearance holes, so these are drilled 1/8 of an inch, or metric, that's 3.2 millimeters. Obviously taking this very, very carefully. Okay, take the drill out, back in with the spotting drill, and unlock the table and bring that round to 180 degrees. Which is there. Again, got to move these around a bit. I think that's going to be okay. to 270. And this is our final hole now. So I've got to reconfigure this again. Put you across there, I think. So. Oops, there we go. In with the drill. So that's our 4 holes in that one. So that part, apart from obviously deburring, is complete now. So we can take that out. So there we are. That's our 4 clearance holes drilled. So what I've got to do next is to drill the other end cap, this one, but this one's got to have a completely different setup. This one will have well, one hole at the bottom, and then if you imagine taking that right round to the opposite side, the 2 other holes will be 45 degrees across from there. The reasoning for that is that when this is mounted into the base, if you drilled these holes in any other way, you literally wouldn't be able to get the little screws through here, through the base and into the cylinder. I did see somebody else making one of these engines, and strangely enough they did actually drill them at 3rd position, so quite how they got round fitting those in, I don't know. I mean, it may be that did work, but I'm going to follow the plans exactly here and drill them as specified. So I've got to give the chuck here a bit of a clean up, and then I'll come back and show you drilling those other ones. Right, well, this is how I've set it up to drill the other cylinder cap. So we're starting at 0 here, and you see I've put lots of little markings on here, basically as a, if you like, a sanity check to make sure I get it right. So after I've drilled that one, the other 2 holes, if you imagine that if you took the cutter right the way round to the opposite side, that's 180 degrees round, and then move the rotary table to 45 degrees that way and 45 degrees that way. So I've put just some Sharpie marks just to make sure I don't start drilling in totally the wrong place. So I'll drill this hole first, and then I'll bring the table round to the 180 degree position, and then run the rotary table round each side. So hopefully I'm going to get this right. Just had to move all the parallels around again, so I don't start drilling through them as well. Right, I'll take the obviously when I set this up, this one, the other cylinder, I did as a check just make sure that the my pointer lined up in that centre hole there, and then ran the table across in the X movement 0.375 to give me the 3/8 offset for them. Right. Okay, well that's the first hole drilled. Now the other two to set up. Take the drill out. And the spotting drill again. Okay, so I'm going to run the table round to 180 degrees. So now I'm obviously exactly opposite here. So now if I move the table round 45 degrees in each direction to drill the other two holes. So that's got to come over, got this on that side. And that should line up very roughly with my Sharpie mark. That's not exactly in place, I just put a spot there just to help me along a bit. Just like the table. Just put that parallel in there just to give it some support as well. Out. Spotting drill back in again. So now if I take that back to 180 again, that obviously brings me opposite that hole again, and I go 45 degrees the opposite, 10, 20, 30, 40 and 5. And I'm sort of near my little Sharpie mark there again. Just going to move all these parallels around. Move that one out and try and get that one over there. Actually put that in that way. So it gives me one which will be at the very bottom of the cylinder, and these two at the top. There we go. Right, there we are. Take the parallels out, and for safety's sake take the drill out first. I'll skewer myself on it, and we can now remove the cylinder cap. So there we are. So I've got my holes drilled in sort of peculiar positions, but that's what the drawing calls for. This one's obviously very important because it's this one that you will use to align the holes in the base and into the cylinder. So this is very, very important because that's going in between the two. So that's, when I drill the holes in the base, obviously I've got to make sure that that is perfectly level when I do that. So there we are. It's the two parts completed now. Apart from deburring, they're basically finished. Obviously, clean off all the setup blue on here and the Sharpie marks. So I'll bring you back for whatever comes up as the next stage. Well, this is where we are so far. I've laid out all the parts for the engine that I've made up to now. The last bit I did was drilling the holes in the cylinder end caps here. Between the cylinder end caps and the cylinder itself, you have a piece of joint material or gasket material. The kit does come with a piece of material which I'm guessing must be genuine joint material, but I don't know. But it happens that I do have some sheets of English-made material, this oil-resistant jointing made by Flexoid. I've got this in a number of different thicknesses, and this sheet, you see I've cut out a piece out the corner to make the gaskets for this one. And I bought this some years back for the various engines I've made in the past. One of the engines I made, I used a sort of joint medium. I think it's the sort of stuff that may be perhaps used in the car industry, I'm not really sure, but it's thick, black, very glutinous material. It was pretty horrible to use, and decided I would never use that again. But off camera, I've actually made the two little joints for both ends. Of course, they're obviously different, but the central hole is the same. Now, with this engine, the bore in the cylinder is 1/2 inch. There's been a number of engines that I've made scratch built in the past, which I've made with the same size bore. And if memory serves me correctly, the Myford Boy engine I made was also 1/2 inch. So to try and get a nice accurate hole in the centre here, let's pop that one on there. So that's got to be orientated around to get sort of a nice fit in the centre. I made a little jig to do this. I just made it out of all sorts of scrap bits of material that I happen to have. So it's got a... Let's move these bits out of the way so you can see it better. It's a base. It's still got the bits of joint material in there, actually. Let's push them through. There we go. So I made this up. I machined a 1/2 inch hole in here, and then I made this part to form a punch. So I just simply put a screw in here which I can mount in the chuck on my bench drill, and then I can, if you imagine using this piece of paper here, you just line this up underneath the punch on the bench drill, or it could be done in the milling machine as well, and then you can just lay the material on here, line it all up, and then just literally push the quill of the bench drill down to punch the center hole, and it gives you quite a nice clean hole in the center. And then simply to cut the other holes, you can just line up the joint paper with the little registration here, turn it upside down, and then just mark the positions through here with the tip of a pencil, and then use another tool to chop the little holes out for the clearance for the screws. And I use one of these tools. These can be bought very, very cheaply. I think this only cost me about £3, and you can see you've got there's this sort of rotating cutters here, all different sizes. This is sort of typically used for, perhaps the most common thing I guess is punching holes in leather for leather belts. So you can put the line up the paper against the little anvil here, and then just squeeze that until it punches the hole out, and that works very well as well for doing this job. So you know, it's a sort of simple method of doing it. And I've made quite a lot of engines that have a cylinder and piston in them, so this little jig's been used quite a number of times. These was literally bits of scrap material, and I think I've mentioned before that whenever I'm making anything in the workshop, I keep literally every little piece of scrap material that's left over, because even tiny little bits of metal, steel, brass, aluminium, whatever, you know, does come in useful later on. So I think the next part I'm going to make, now I've got the cylinder done and the end caps done, this is the piston rod with the stuffing nut there in the centre, you see. I think I'll make the piston next. The kit gives you a piece of brass to make this out of. It is oversized to the cylinder bore, but I guess that's if you get sort of variations in size here. When I managed to get the piston bore here quite accurate to the 1/2 inch, and I used a piece of 1/2 inch silver steel to check that, and I had a very, very good fit. So this obviously then needs to be turned down, so you've got a not quite a sliding fit, but a fairly loose fit, because the piston has a cup. The piston's only about 1/4 inch long, but it has a couple of grooves in it to take some it's like sort of piston rings, which are, let's say on my list here what they're actually made out of. It's bear with me a second, I'll find out what the material is. It's Teflon, little Teflon rings with a sort of a split in it so that you can snap them into place. The little grooves are only about 50 thousandths wide, so I didn't have any grooving tools of the right size to do this, so I searched through a lot of bits of high-speed steel that I had, and I got a little tin of high-speed steel tools with the Chinese mini lathe when I bought it, that the original owner had made all sorts of cutting tools out of, and this was among them. I've got this already mounted in the tool holder here, and I put a mark here. It's 0.050 in width. It was near to that size, but I've ground the edges and squared up the ends as well, because originally this one had a round end to it, obviously made for a specific use. And I've already done some tests with it on not to sort of size, on a bit of aluminium. I just machined a bit of aluminium down, and I made some various tests to it. The critical thing, I guess, really is getting the right depth for this. That's obviously going to be the more difficult thing to do. But there's not an awful lot of brass here to make it out of. Obviously sufficient here to hold it in the lathe chuck. And I did look through my own stock of brass, and I don't have any brass of this size, half it. Well, this is actually over ½ inch. As a sort of a standby, but obviously if I don't manage to make this well enough, I could always get hold of a piece of nice machinable brass to make another one out if I need to, but I'll just see if I can manage to drill this correctly. It will have a centre hole here to take I'll take that nut off the end here so you can see what I'm talking about. It will have a hole drilled in it to take this little shoulder here, and it will have a counter bore also for the screw thread part, which will take the little fixing nut on it. So that's got to be the counter bore, obviously has got to be drilled quite accurately as well. So I think that's going to be my next job. I've got to obviously take down the my rotary table, take the dual chuck off it, and the lathe chuck off it, and put it back on the lathe, get it all set up again, and then have a go at doing the cylinder. So I think that's going to be the next thing along. Hope you'll join me for that. Well, next I'm going to have a go at making the piston. I've mounted the piece of brass that was supplied with the kit. This is, as I mentioned I think earlier, this is oversized. This is 0.531, so this needs machining down to a diameter of 0.498, 0.02 of an inch less than the diameter of the cylinder bore. I have already faced off the side of it here, no need for you to see that, that's quite straightforward. But what I also need to do is to drill a hole right the way through 3/8 of an inch, and then machine a counter bore in the end here. The counter bore needs to be 5/16, so to give I could do it with a drill, but because the little locking nut will lock against that, I'm going to try and do it with a 5/16 end mill. So that will give me a nice flat bottom. It's a nice, I don't like using end mills in a lathe chuck, but it's only got to be drilled 1/8 of an inch deep, so I'm hoping that's going to be okay. the only way I can think of easily doing this to get the right depth is to actually use the scale on the tailstock quill. It is actually marked in imperial sizes, each gradation being 1/8 of an inch. So I think if I'm very, very careful, I can actually get it to that measurement. If I overshoot this, then of course I could then sort of reface the end off here to bring it to size, but I'm going to be as careful as I can in machining that. I guess it's a fairly critical measurement. I mean, I suppose a thou out either way possibly wouldn't make a great deal of difference, because the piston shaft it does give us sort of a registration as well. So anyway, let's see how we get on with this. Anyway, so as I mentioned, I've faced this off already. So I think I'll just drill the holes first, and then I can machine this down to the right diameter, the right length. Obviously, once I've done the machining here, if I need to, I can sort of reface the surface off to clean it up as well. So let's see how we get on with this. We'll spot this first. Right, immediately there's a problem. Of course, my big chuck here won't close down enough. It only closes down to 3mm, so I just need to change the drill chuck over. I'll swap the drill chuck over. Obviously, it pays to have a smaller one for the lathe as well, as the other keyless chuck I've got obviously is too big for some very, very small operations. And that's it. I just need to reset up now to do the counter bore next. As I mentioned, it pays to have a small drill chuck for your lathe as well. This is an American-made Jacobs chuck, so it will cover all the very, very small drills as well. This one's on a size 1 Morse taper with a Morse 2 taper adapter. I've got another one of these, exactly the same type of chuck as this, that I use on well, you've probably seen that a number of times. I use it on the milling machine because I often seem to be drilling very, very small sizes, so it's very, very useful. I've been looking out for a very, very small keyless chuck. Seem to be very, very difficult to find and very expensive as well. There don't seem to be a lot of keyless chucks made quite this small actually. I know Albrecht do one, but you'd need to remortgage your house to be able to afford one of those, but I guess I'll find one day. Anyway, I've got this set up now, and I've just touched it's a 4-flute end mill, but what I did first was set the quill to a particular marking on the tailstock quill rather, so that I can bring this back and then drill in until I reach that point again. So I've got the tailstock locked nice and tight. Got a horrible feeling that this is going to be rather a noisy job actually, because even drilling into brass it screams. So we just have to see what happens. If it makes too much noise, I'll switch the camera off for a minute. Anyway, let's see what happens. Got to take a chance on it. I've not done anything quite like this before. I'm running the lathe a little bit slower. I don't know if that's going to help or not, but let's see how we get on with this. You can see it's leaving quite a bad little nub inside there, and unfortunately I don't have a 2-flute end mill in this size, but what I'm going to do, once I've got this down to size, if in fact it will machine into that depth, and well, it has actually reached it now. I am actually an 1/8 in. I have got a smaller 2-flute end mill, so what I'm going to try and do is to machine that little nub out down to the depth that this has created. It didn't work out quite as well as I hoped it would actually, but I suppose what I could have done was use even if I'd have used the drill, I guess that might have been better, but what I'm going to try and do is machine that little nub out back to the flat that this one's created. Well, what I've done is I've taken a bit of that nub out with a 2-flute end mill, which would give me a flatter base, but before I did that I actually measured the depth around the sort of outside, and in fact I hadn't gone in the 1/8 that I required. I think what had happened is that the nub was actually restricting the depth that 4-flute end mill would machine down to. So I machined off a bit of the nub and then put the 4-flute 5/16 end mill in and drilled it down again. I'm actually, on measuring it, I think I'm could be just a fraction over, but of course measuring the depth, you've got to also take into account there's a bit of a burr here as well. So I'm probably about 10 thousandths deeper than I need to be. So I'm going to machine that little nub out of the centre as best I can, then take some other measurements, and what I can then do is obviously face this off to give me the correct depth. I think that probably is the answer. Well, visually, it looks as though that's worked. I'm to move the tail step right out the way. Let's try and clean that out a little bit. Well, that does appear to have worked. Right, and I'll take a measurement. It's going to be a bit out because of that burr. Let's see what we've got. Let's zero this up. Yeah, I can see this is standing off a little bit there. So yeah, I reckon. Let's measure it from the top as well. See one up. Yeah, I'm actually not that far out. Actually, I'm only about 6 thou out. So what I'm going to do, I'll do this off camera so I can sort of concentrate on what I'm doing. I'm just going to lightly face that off again and then try and bring that to measurement. But looking through here, there's a little torch. It looks as though I've got a nice flat base to it. So I think if I can bring this to size, that's going to be great. That's going to work out fine. So I'll do that bit off camera and bring you back when I'm ready to then start machining the outside down. Well, I've fiddled around with this off camera, taken a couple of sort of light passes across the front, and at least I've sort of cleaned up the edge here of the hole in here. So I've probably got it about as good as I'm going to, I think. Whoops. Move the thing again. Move this without moving it. So I'm at 125. It's actually showed 125.5 to 126. So this is, well, hopefully that's going to be okay. I do notice around the little 3/32 hole, there's a little bit of a burr on that. So when I take this out, I just have to sort of try and clean that up a bit so that when the piston shaft goes through from this side, that the nut that holds it in place will lock down onto the face inside here comfortably. So what I've got to do now is bring this outside diameter down to 0.498. I took some measurements. I've probably got about, I wrote it down somewhere, about 33 thousandths to come off, approximately. So let's have a go. Right, I need to take a measurement on that to see where I am. Let's have a look. Well, by my reckoning, I've got about 8 thousandths still to come off, so I'll go very, very gently now. Five, 9. Well, I don't know if you're going to be able to see. I'm probably not at all. I might just be able to see it. So I'm reckoning that I'm virtually spot on. There may be a couple of tenths in it. If I move the thimble round to there, that would be the correct measurement, but I'm about there, so there's a couple of tenths. So for me, that's probably about as near as I'm ever going to get it, actually. So what I've got to, well, the final thing before I part it off is to do the little grooves. Not something I'm particularly looking forward to, but so the overall length of this part is going to be 1/4 inch, and there's 2 grooves. So taking the measurements, there all of the measurements are 50 thousandths apart. So you've got 50 thousandths, a groove, 50 thousandths, then 50 thousandths, another groove, and another part. So that's 5 lots of 50 thousandths, which is 1/4 inch. So I'm going to use the little ruler here to sort of set this up as best I can. And we'll see how we get on with this. I guess as long as you get a reasonable spacing between where the little grooves are, you're probably okay actually. But the critical thing is getting the right depths, because I'm guessing that the outside edge of the little piston rings just make up that 0.002 difference. So it's really only got to be proud of the surface here by 1/1000 of an inch. Quite critical really, but anyway, I'll try and set this up, and let's have a go at cutting these little grooves next. Okay, well let's have a go at the cutting these little grooves. So I've got the grooving tool mounted in the lathe here. So this measures, as near as I could get it, 50/1000. So if I bring that in here and I put a razor blade against that surface and bring that across so that it touches the razor blade, okay? So that should be, if you like, the first wall of the of where the grooves are. So now if I use the top slide, which I'm hoping is going to be accurate enough, use the vernier gauge on the top slide, bring that across to 50 thou, and I'm also doing this lock in the carriage so nothing moves there, because I'm relying now on using the top slide. And now what I've got to do is to machine in, I reckon, look at my calculations, 54/1000. So let's see how we get on with this. I'll slow the lathe down. You know, the sort of speed I would use if I was parting off. Let's see how we get on with this. This is one of those occasions where I wish I had the DRO on the lathe. Probably something like that. This would help absolutely no end, because I could rely on using the carriage to move this along. Obviously I couldn't have the DRO on the, I guess couldn't have it on the top slide, but I could have it on the carriage and then move the carriage along, activating the DRO and locking the carriage. That would do the same job, I think. Anyway, we'll see how I get on with this. Right, that's 54/1000. Now, what I need to do is to move across another 50/1000, which is there, which would be like if you like the second wall of the groove, and then move across another 50/1000. Is this making any sense? And the second groove now. I'm going to bring that in just to touch that off there. Yeah, back to, because I've set the I said vernier earlier. I mean micrometer dial that I've got on the cross slide. That's what I meant to say, but I didn't say that. Right, so I've started the cut at 0. So I hope I've got that. So if I run that in and then move that across another 50 thousandths, that should in theory bring me the outside edge of the little grooving tool should be at the 1/4 inch. Yeah, damn it, the the imperial measurement is correct at the top here. The bottom's 20th. Let's see if I can. You won't be able to see what I'm doing here, but well, as near as I can see, the if you like, my left-hand edge of the grooving tool is at a 1/4 inch from this surface here. It seems to have done quite a nice job of it, assuming that I've got it right. I'm going to move that razor blade out of the way for a start. Let's move this right across out of the way, and that's where I am. Bear with me a second, let me just try and bring this camera in a bit closer. I couldn't have the camera here obviously while I was working on this, but so that's basically where I am with it. So obviously you've got to just drop these. These are the little Teflon piston rings, and you see they've got where is it now? Somewhere in here. Oh, can you see? Oh, let's get this. Can you see they've got like a little slot in it, so that you've got a means of like opening this out just very slightly so you can pop them on. So I'm hoping this is going to do the job. I won't be able to tell until I've fitted those and put the I don't know if I brought up any burrs on there, but I did try the piston on. Actually, when I tried it before I cut these, this slid on with a bit of movement. Actually, I've got it on the end there. It goes on and there's a bit of movement. Obviously there is a burr here, so I'll have to very, very carefully take that off. Might try and do that with a bit of Scotch-Brite. I don't want to, or I'll try and find one of my tiny Swiss files to clean that up. But what I'll do a clean up on this, get the rings on, and then we'll do a test fit before I part it off. So I'll bring you back for that. But well, I've used a tiny Swiss file, a square one. This to just take the burrs off the edges to make sure the cylinder would slide over, which it did, like it did before I started cutting the grooves. And I popped the little Teflon piston rings in, and that slides on okay, and there doesn't seem to be any movement there at all, so that looks as though it's going to be fine. I mean, I never think a piston doesn't need to be really tight, because if it was, it's going to jam inside the cylinder. I think that with these little model engines, there's really enough for not a loose fit, but a nice sliding fit for the piston to work nicely. So what I've got to do now is very, very carefully part this off to length. But that's, it all goes well. That's quite a simple thing to do, so I can do that little bit off camera. But I'm quite pleased that they've gone on all right, because I'm hoping that when I knew that I had to fit these, that they wouldn't be the thing I'd have to keep taking on and off with the worry of snapping them or damaging them. So I think that fits quite nice. Obviously there will be, you know, some oil on here to smooth them at running through, but the piston seems to go on quite nicely, so I'm sort of quite happy with that now. Because I did, well, if I put it on that way, that's the this is the side which will the side that goes up to the base, and it fits equally well on both sides. You know, when I did measure the bore in the cylinder very, very carefully to make sure that there's no tapers in the bore itself, so that's fine. So that's a nice part to have made there. So what I'll do now is I'll part that off, and we'll have a look at that. Perhaps I'll put it on the piston rod, and we'll have another look at it. Well, that's another little part completed, the little piston with the little Teflon piston rings on it. I think with making all the parts of this engine, really, you can't take anything at all for granted, that everything you make has its difficulties, but really, you know, a lot of care's got to be taken with everything you do. So I've mounted this on the piston ring. It's the little stuffing up there, and this end connects to the what part? I've forgotten the name of that part now. The part which is called the crosshead. That's it, the crosshead. So on the thread that goes through here, there's a little shoulder that goes through the little hole in the back of the piston there, and then you've got this tiny little hex nut that locks it on. I'm not going to put that on really tight, really going to wait till the whole thing's assembled. I've put a tiny bit of light oil on that, and also in the cylinder. I've got to look round the camera while I do that, so that will pop in. And it runs reasonably well through there. Probably needs a little bit more oil in it, but I guess with all these parts, the piston particularly is going to have to bed in. But I think that's quite nice actually. I'm quite pleased with how that's worked out. I was quite nervous of doing this part actually, particularly the cutting the grooves, because when I not only had to sort of modify that little tool to do this. I'm not the greatest person in the world at grinding tools, but it did come out quite nice in the end, and it's given me quite a nice fit. So I'm obviously very pleased on that count as well. So there we are. That's that part done now. Quite happy with it really. So I think now there's only another couple of parts probably to make, but I think what I'll probably do next is set up the base so that I can drill the holes through here, line it up with the little end cap. So that will go through there. So I can line this up and then mark out the positions on this end of the base, so that I can fit that. Once again, it will be clearance holes in the base as well, so that the little screws will go through from this side through to the cylinder, and it's the cylinder that will have the threaded holes in it. So that's going to be all of this. Well, everything is a bit of a challenge anyway. So I think I'm going to do that next. And while I'm doing that, I'll also once I've got that in position, nice and level, of course, then I can put the cap at the other end of the cylinder and line that up so that the four little screws line up nicely. So I think that's going to be the next thing, and that will be for the next video along. So thank you again for joining me in the workshop through these little parts, and again, you know, thanks to everyone that's subscribed to the channel. If you haven't already, you know, I'd love you to subscribe to the channel and come along with me on this little adventure of building this engine. If you've got any comments, if you can see that I'm doing anything pretty obviously wrong, which is most of the time actually, let me know. I'm pleased to have any advice. You won't offend me one bit. I like to sort of learn how to do stuff. You know, I mean, a lot of this is very much, if you like, making up as I go along. But any advice is more than welcome. So there we are. That's it from me, and I look forward to seeing you in the next one. Bye bye for now.